This is Professor Darev's Sites. This algebra tutorial is part 4, the last part of a series focusing on solving quadratic equations. This part is about the quadratic formula. The quadratic formula is used when your quadratic is in standard form, so you have to get it in standard form first. Ax squared plus bx plus c equals 0, and the formula is x is negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice that this entire top is all over the 2a. The 2a is not just under the minus b. The quadratic formula can be derived from using the completing the square technique, starting with the standard form. The quadratic formula is the most powerful technique for solving quadratic equations, but because it can be used to solve any quadratic equation once it's written in standard form. Be careful to make sure that you carefully identify a, b, and c, particularly avoiding mistakes with their sign. Related to the quadratic formula is the expression under the radical sign. It's called the discriminant. And the value of the discriminant can be used to differentiate the types and number of solutions that you have depending on whether the discriminant is greater than 0, equal to 0, or less than 0. This is not hard to understand. If this expression here is 0, then its square root is 0. Plus 0 and minus 0 are both 0, so you end up with just a single solution. And we note here, when it is equal to 0, you have one real number solution. If this discriminant is greater than 0, then you get square root is a positive real number, and you're adding it and subtracting it from this other term here, you're going to get two different real number solutions. If the discriminant is negative, the square root is going to introduce a complex number here, and you're adding and subtracting it, so you will get two complex number solutions that will be conjugates of each other because of the plus or minus. Note that the complex conjugate of a complex number a plus bi is simply a minus bi, and vice versa. Example 1. X squared minus 2x minus 2 equals 0. First, identify a, b, and c. A is 1, the coefficient here of the second degree term. B is negative 2, and c is negative 2. Substituting these values into the quadratic formula carefully, you see we get this expression here. Simplifying the radical, we get square root of 12 under the radical. So 2 plus or minus the square root of 12 over 2. 12, however, has a perfect square in it, 4, so that's 4 times 3. And we're taking square roots. The square root of 4 comes out as a 2. We end up with 2 plus or minus 2 times the square root of 3 over 2. We have what's called a cancel triangle here. The 2's form a little triangle, and you can cancel when you have a cancel triangle. It's the same as if you factored out the 2 on the top and then canceled the 2's. So we get 1 plus or minus the square root of 3. Two answers, 1 plus the square root of 3 and 1 minus the square root of 3. Since the discriminant, as we see here, is 12 and is greater than 0, this implies two real solutions. Here's a graph of the quadratic, and it's a parabola, and we see that it crosses the x-axis in two places, and those places are 1 plus the square root of 3 and 1 minus the square root of 3. Example 2, x squared minus 2x plus 1 equals 0. Identify a as 1, b as negative 2, and c as 1. Substitute these values into the quadratic formula, and the discriminant here is 0. We're taking the square root of 0, and we just get 2 over 2 is 1, a double root. It's a single solution, but it's called a double root because with quadratics it would appear twice as the same factor. The discriminant is 0, one real solution. Notice that there's only one place where this parabola touches, does not cross because that would give two solutions, touches the x-axis. The last example, x squared minus 2x plus 2, a is 1, b is negative 2, c is 2. Substituting these values into the quadratic formula and being very careful, we notice here that we're going to end up with the square root of 4 minus 8, which is the square root of negative 4. So the discriminant, negative 4, is less than 0. We'll have two complex solutions. Simplifying here, the square root of negative 4 becomes 2i. There's a cancel triangle, so this becomes the 2's cancel all the way. We get 1 plus or minus I. Those are conjugates of each other. And this parabola for this quadratic, as you can see, does not cross the real axis at all, indicating that there are no real number solutions. The quadratic formula, then, as we see, is the most versatile of all the techniques, but you must be careful with it. It's often easier to use one of the other techniques depending on the problem type that you get. And also we have the benefit of the discriminant quickly showing us the kind and number of the solutions.